This is a series of lectures on fundamentals of measurement and force analysis, understanding units, dimensions, and core concepts. I'm Mohammad Nazari Sharabian, PhD PE, and Assistant Professor of Civil Engineering at West Virginia State University. Let's start with units and dimensions, and let's talk about the importance of measurement in science and engineering. Measurement is super important in science and engineering. It's how we make sure things are not only accurate, but also consistent. It lets scientists and engineers put numbers to what they see, test their ideas, and make sure their experiments can be trusted. When we have precise measurements, we can compare results, make detailed calculations, and even standardize processes. This consistency is crucial because it allows others to repeat the results, and that's how progress happens. Without good measurements, advancing technology or understanding the world would be nearly impossible. It's the foundation for making smart decisions and pushing improvements forward. Units and dimensions give us a standard way to express and compare measurements. They help keep things consistent and clear, making it easier to communicate quantities across different fields. And when we use units and dimensions correctly, we avoid misunderstandings and errors, especially in calculations and conversions, where even small mistakes can cause big problems. And by sticking to a common framework, units and dimensions make it possible for people to work together, repeat experiments, and push forward with scientific research and technological advancements. Alright, so here we have units. Units are the standardized measurements used to quantify physical quantities. So you see examples here as meters, kilograms, and seconds. And on the other hand, we have dimensions, which are the physical nature of quantities. And examples of them are length, which can be shown in brackets by L, mass shown by M, and time shown by T. The SI, or the International System of Units, and Imperial units are two different ways to measure things around the world. SI, which is based on the metric system, is the most commonly used and makes things simple and consistent with its decimal-based approach. You will see it a lot in science, engineering, and most countries. On the other hand, imperial units are still used in the US and a few other places, but they are based on older systems and can be trickier because the conversions aren't as straightforward. And while SI units help people work together globally and avoid mistakes, the imperial system still has cultural importance where it's used. Let's look at 7 fundamental SI units. So first one is meter, abbreviated as M, which is the unit of length. Next one is kilogram, kg, which is unit of mass. Second, S is the unit of time. Ampere, A, is the unit of electric current. Kelvin is the unit of thermodynamic temperature. Mole, MOL, is the unit of the amount of substance. And finally, candela, CD, is the unit of luminous intensity. Now let's look at some sample imperial units. So here we have inch, foot, yard, mile, acre, gallon, fluid ounce, ounce, pound, degree Fahrenheit, and pound per square inch. So these are sample imperial units. This table compares SI and imperial units. For example, for the measurement type length, the SI unit is meter, while the English unit or the imperial unit can be inch, foot, yard, or mile. For mass, the SI unit is kilogram, while in English or imperial units, ounce, pound, or ton can be used. For volume, the SI unit is liter, but in English unit, fluid ounce, pint, quart, or gallon is used. For temperature, the SI unit is degree Celsius, while in English units, it is degree Fahrenheit. For pressure, the SI unit is Pascal, while in English units, it is pound per square inch or PSI. For energy, the SI unit is joule, while in English units, it is British thermal unit or BTU or calorie. For power, the SI unit is watt, while in English units, the unit is horsepower or HP. For force, the SI unit is Newton, while in English unit, it is pound force. And for area, the SI unit is square meters, and in English units, it is square inch or a square foot or acre. Now let's talk about the advantages and disadvantages of the SI and the imperial system. Regarding the advantages in the SI system or the metric system, it is decimal based, which is easy to convert units. It is globally accepted, which facilitates the international trade. It is standardized and consistent across scientific fields. It simplifies scientific and technical calculations, and also this SI units uses a unified system of prefixes such as milli and kilo. And regarding the disadvantages of this SI system, it can be unfamiliar in countries using imperial systems such as the US, and also requires learning new units for those accustomed to imperial. And regarding the advantages for the imperial system, familiarity in the United States, historically entrenched in certain industries, and also common use in everyday activities in the US. And disadvantages are the following: non-decimal, which is harder to convert between units, limited international use, hindering global collaboration, and inconsistent units, for example 12 inches in a foot, 5,280 feet in a mile, and also more complex for scientific calculations. This slide shows some important unit conversions. For example, for length, in order to convert meter, which is this SI unit, to imperial unit of foot, 1 meter is approximately 3.28 feet. Another example, kilometers to miles, 1 kilometer is approximately 0.62 miles. Other examples are mass. For example, in order to convert kilogram to pound, 1 kilogram is approximately 2.2 pounds. Other items here in this table are volume, temperature, pressure, energy, and power, in which you can use these unit conversions in order to convert from SI units to imperial units and vice versa. The SI system of prefixes. The system of prefixes allows for clear communication of scale without the need for cumbersome numbers. So let's look at some examples. Millimeter. A millimeter is equal to 10 to the negative 3 meters. This unit is often used in measuring small lengths. Another example that we hear a lot, especially when working with computers and hard drives, flash drives, is gigabyte or GB. A gigabyte is equal to 10 to the 9th bytes. This is commonly used to measure digital storage capacity, such as the size of a computer's hard drive. So in this table, which has 21 rows, we have different prefixes. And the ones that you see in this red box are the ones that are more commonly used. As examples, we have nano, micro, milli, centi, etc. Alright, let's work on some unit conversion examples. Question number 1, convert 10 feet to inches. So based on unit conversions, we know that 1 foot is equal to 12 inches. And in order to convert feet to inches, or in any unit conversion question, we have to use fractions. Because, for example, here, if we multiply this fraction by this fraction, foot and foot as the numerator of the first fraction and the denominator of the second fraction, they cancel out. And what we are interested in is inches, so the final answer will be in inches. So 10 foot over 1 times the unit conversion, 1 foot is 12 inches, equals 12 times 10, which is 120 inches. Again, 10 foot is equal to 120 inches. Next question, convert 150 grams to kilograms. So we know that 1 kilogram is equal to 1000 grams. Again, we have to use fractions, and we want gram to cancel out, and we want to get our final answer in kilogram. So it has to be the numerator of the second fraction. So as we multiply 150 grams by 1 kilogram over 1000 grams, we get 0.150 kilograms. Therefore, 150 grams equals 0.150 kilograms. Next example is convert 0.66 liters to milliliters. So based on unit conversions, we know that 1 liter equals 1000 milliliters. So 0.66 liters times 1000 milliliters over 1 liter equals 660 milliliters. Again, we are using the form of fractions. We want our final answer be in milliliters. Therefore, liter in the first fraction and liter in the second fraction should cancel out, so that what remains is milliliters. Therefore, 0.66 liters equals 660 milliliters. Another example, a certain map has the following scale. 1 inch equals 5 miles on the map. So this is the scale of the map. If the distance between city A and city B is 8.6 inches on the map, what is the distance in miles between the two cities? So we know that the distance between the two cities on the map is 8.6 inches. And we know that 1 inch on the map equals 5 miles. So we have to cancel out inch and get our final answer in miles, because that is what the question is asking, that what is the distance in miles between the two cities. So if we multiply this fraction by this one, inches cancel out, and what we get is basically 8.6 times 5, which is 43 miles. So the real distance between city A and city B is 43 miles. Next question is convert 225 inches to yards. So for this example, we have to use 3 fractions, because first we have to convert from inches to foot and then from foot to yards. So 225 inches multiplied by, we know that 12 inches is 1 foot, so inch and inch cancel out, and what remains here is foot, and then we multiply by another fraction to cancel foot and get yards. So we multiply by 1 yard is 3 feet, so foot and foot cancel, inch and inch cancel, so what remains is yards, in which is what we are interested in. So 225 times 1 over 12 times 1 over 3 equals 6.25 yards. Next question is convert 1000 feet to kilometers. In this example also we have to use 3 fractions, because first we have to convert from feet to meters and then from meters to kilometers, which is what we are interested in. So 1000 feet over 1 times 1 meter, that equals 3.28 feet, times another fraction, 1 kilometer is 1000 meters. So feet and feet cancel, meter and meter cancel, and we get kilometers. So if we multiply all these three fractions, we get 0.30 kilometers. Again, 1000 feet is equal to 0.30 kilometers. Next question is convert 6,000 milliliters to gallons. Here we have to use three fractions. So first we have to convert from milliliters to liters, and then from liters to gallons. 6,000 milliliters over 1 times 1 liter equals 1,000 milliliters. So milliliters and milliliters cancel out, times 3.785 liters equals 1 gallon. So here also liters and liters cancel out. So the final answer will be in gallons, which we are interested in. Therefore, if you multiply this fraction by this fraction by this fraction, we get 1.585 gallons. So 6,000 milliliters is equal to 1.585 gallons. Another example is a book weighs 3 pounds and 7 ounces. What is the mass of the book in kilograms? So first we have to convert 3 pounds to kilograms, and then 7 ounces to kilograms, and then add these two numbers together. So in order to convert pounds to kilograms, we should use this fraction. 3 pounds over 1 times 2.2 pounds equals 1 kilogram. So the final answer is 1.36 kilograms for this first portion. Next portion, converting ounces to kilograms. So 7 ounces over 1 times 16 ounces equals 1 pound, times 2.2 pounds equals kilograms. So pound and pound cancel, and ounces cancel. So we get equals 0.20 kilograms. So next we have to add these two numbers together. So 1.36 kilograms, which was the 3 pounds, plus 0.20 kilograms, which was the 7 ounces, equals 1.56 kilograms. Next question is convert 45.7 millimeters to meters. So we have to use two fractions, converting millimeters to meters. So 45.7 millimeters times 1000 millimeters is 1 meter. So millimeter and millimeter cancel out, and what remains is meters. So that is equal to 0.0457 meters. We also can write these fractions in the following form. 45.7 millimeters over 1 times 1 millimeter equals 1 times 10 to the negative third meters, which equals 4.57 times 10 to the negative 2 meters. So this number and this number are the same. Next question is convert 765 nanometers to millimeters. So here we have to use three fractions. First we have to convert nanometers to meters, and then meters to millimeters. So 765 nanometers over 1 times 1 nanometer equals 1 times 10 to the negative 9 meters times 1 meter equals 1000 millimeters. So as you can see, nanometer cancel, meter cancel, and what remains is millimeters. So if you multiply these three fractions, you get 765 times 10 to the negative 6 meters, which can also be written as 7.65 times 10 to the negative 4 meters.